Hey guys, just thought I'd give a little walk around of this CNC router I built for my father-in-law. He's a woodworker and always wanted a CNC machine. He's retired now, so I figured I'd build one for him. So I've been making this thing for a few months now. Put a lot of thought into it, and I thought I'd share the my experiences with some of these components, and what I think I did right and what I think I probably could have changed for next time. So this machine is about 2 feet, sorry, it's about 48 inches wide in the cut and about 36 inches or 30, I think it's 32 inches in the Z. It overhangs the table a little bit so that he can bolt things to the front of the machine and cut the end grain. So it's all linear rails, it's ball screws, 10 millimeter pitch on the X and Y and 5 on the Z, 15 millimeter rails all around. Oh, well, this one's something I had laying around and just used for this. So that's kind of a beastly one, but yeah, the table's all steel. Underneath it's a steel frame and then a wood MDF top with holes drilled in it with inserts. The whole table is gridded underneath this vacuum table. I've got the ball screws got repacked by me so that there'd be no backlash. One of them was a little bad, so I put oversized balls in it. It's all good now. Got a 2.2 kilowatt spindle, water cooled, and runs up to 24,000 RPM, which is a lot. So all the motors are NEMA 23. The X and Y are 1100 ounce inch-ish, I think. Plenty of power. It's got solid couplers, got inductive limit switches. Really, it's only using this one and this one on each axis. This was a home switch for Mach 3, but I decided to not use Mach 3 anymore. It's on UC-CNC. We've got the selector switch for the vacuum manifold to block off the leftmost and rightmost zones. Got a one-shot oiler, which works pretty well. The only thing I don't like about it are these manifolds, which suck. They leak, and they're not good to use. So if I had to do it again, I would not use those style. We've got a air blast and mister, so you can cut aluminum here and point this thing at your tool and cool everything off. Make sure you don't have any chip welding. The Z motor is a little smaller. I think it's like a, I don't know, 400 ounce inch or something like that. It doesn't need to be as strong because basically, it's got a finer pitch screw and it's not moving as fast and it doesn't have as much to do. So we got a little monitor stand. This thing can move around, pull it around and put it where you want it, kind of thing. Touch screen. So basically, we've got the UC-CNC controller here. Works great. This is a 2017 screen set, which also works great. Helps out with the probing between tools, which is super convenient. Just being able to command a tool change, have the machine come out to about here, change the tool, it'll go over, measure the new tool offset over there, and then keep cutting. It works really well. Yeah, I don't know how people do this without that step, because if you have to change tools on a router with wrenches and everything, and then have to measure the tool every time, like that sounds pretty awful. So this works great. As far as the probe, I've got another tab here for a touch probe if he ever gets one, or if I make him one. So he'll be able to do other probing routines for like geometry on the part. It's built on top of a Harbor Freight toolbox. It's like their Yukon 46 or 42 or whatever. I think it's a 46. Got a nice little drawer here that he's going to make some bins. A couple of cabinets below. Yeah, just something convenient for it to sit on, so that when he's out in his garage cutting and making little projects, we'll have a place to store all the tools. So this is the cabinet. Got the UC CNC controller, the stepper drives, everything's on its own breaker. Got a power supply for 12 volt and 5 volt, 24 volt, 48 volt, and that's for the monitor. That's the spindle VFD. It's a cheap Chinese 2.2 kilowatt, 220 volt unit. I've got it on a filter so that they're not introducing any crazy voltages in the supply. That's just a cheap HP business computer. Does pretty well at Fusion 360. It's a little slower than my main computer, but you know, for him, it's better than a laptop, and he'll be able to run the machine and do all his CAD and CAM on the same computer. Got the water cooling radiator for the spindle, so it's on a variable speed fan system. So basically, if it's cold in his shop, the fans won't run unnecessarily. So they're sensing like the heat at the top of the cabinet where all the heat will go, and not turn on unless they're needed, so that it's not just sucking up dust all the time and making a bunch of noise. Tried to label all the wires the best I can, you know, for future diagnostic in case. Well, he's in Michigan and I'm in South Carolina, so basically I can't drive out to his house and fix it. He needs to be able to fix it himself. So we got a C11G for the basic input-output. We got a C79 for the limit switches, the inductive limit switches. They're 24 volts. And then we got the UC400 ETH controller. That's feeding those things. Everything's, we got a contactor for turning off the 48 volt power supply and the VFD when you hit this e-stop. And the e-stop also breaks the C11G, or it sends a e-stop command to the C11G, so it turns off the drives both ways. Yeah, everything in the cabinet's 220 volts, except for the vacuum motors, which are on 110, but they're each on their own leg. So even the computer's 220, so everything's balanced. We've got some dust mitigation here. Dust ingress mitigation, just a filter I made. It's got a 10 by 10 furnace filter in there, and then like a fiberglass filter above that, and then a grate to keep fingers out of it. Got the nice little PC water cooling loop here for the spindle, and just running antifreeze in it so that it doesn't freeze in his shop. Try to do an okay job at managing all this wiring, but you know, these spindle motors came with a bunch of extra wires, so I didn't take the time to chop them all up. I guess it's not a big deal. There's the air solenoid for the air blast and the mist cooler. What else do I got back here? Oh, here's the motors. So they're 3-stage vacuum pumps, and for like central vacuum systems, and they work great. They're really loud. I'm probably gonna see if he can get a muffler on the outlet of this one. I'm not sure if they need to be in parallel or series. Haven't really done much testing with them, but they seem to do well in series like this. So the way that this vacuum system works is these pieces of MDF are the manifolds, and there's 4 zones here, and the air goes through these inserts into the table, these fixturing inserts into the manifold. and goes into these pipes and goes into this dust collector, which if any crap got into the manifolds from the table, it'll catch them before they go into the motors and ruin the motors. So that's what this bucket's for. And then these two valves shut off the leftmost and rightmost zones to kind of concentrate the vacuum in one spot if needed. Got the one-shot oiler. So yeah, so basically the vacuum works great. I mean, I'm going to turn it on real quick. It's going to get a little loud, but you'll see how strong it is holding this piece of wood down. So I'm actually pushing the machine across my floor right now, and it's, you know, this thing isn't going anywhere. There's really, I mean, I can kind of move it if I really put my whole weight into it. So, yeah, it does a pretty good job. And half of it's on that right zone, or a little bit's on that right zone where it's not getting sucked down because the zone is off. Sorry, that's being blurry. Not really paying attention to the focus on this thing. So anyway, where was I? Yeah, so there's a little control panel that I lasered out. Got the on-off switch, the e-stop. Here's some detail on the spindle. All these pieces of billet aluminum I cut out on my old CNC mill, getting a Fadal over there in the corner shortly. So that'll be here tomorrow. And if I do one of these in the future, I'll definitely be using that machine to do it instead. But yeah, so I cut all these out on my little CNC machine, my old one, and I think it turned out pretty well. I probably could have gone a little easier on these pockets and stuff. I was trying to keep things a little light, but in retrospect, I probably could have kept this, you know, the full plate, and it would have been fine. First cuts. Seems to be doing all right. Hopefully I programmed this well. This is a part for the CNC router I'm building for my father-in-law. This is the Z back plate out of a piece of scrap. Seems to be doing pretty well. probably need to speed that part up. That's pretty slow. Looks like my new toy is working. Seems to be doing pretty well. So the gantry is aluminum extrusion, that's 50 by 100 millimeters tall. So it's fairly stiff. The beam or the angle aluminum that I bolted to the back of it stiffens it some more. And then I think these rails, the way that they're mounted, especially this one's really stiff. These rails add stiffness too. The frame is all steel. Welded, so I did all the welding, and I machined the faces where the rails mount on my Bridgeport at my other shop. And these are all machined flat. All the surfaces of all the steel that I welded in here, where it's actually mated to something, it's all machined flat. So, you know, I try to keep it pretty planar. The table itself, according to my measurements with the Starrett 48-inch straight edge, is flat within 5 thousandths, which is plenty for a wood router. If I was a mill, I would be less impressed, but for a router, I think that's pretty good. And then the table itself, after these get bolted onto it, everything got machined flat, so it's all very planar. What else? So the axes run at about 400 inches a minute for X and Y, and then Z is like 250 because the pitch is finer on the screw, 5 millimeter instead of 10 mil. And I think that's pretty fast. It's certainly fast enough to get you in trouble. I can't really foresee a situation where you need to cut faster than that. So yeah, it works really well. So the one-shot oiler lubes everything in the system: the ball screws, the linear rail, bearing blocks. There's actually some in there too. Go to the back side here. Got one in the X bearing block or ball screw, and those guys got oil too. So everything's lubricated. All the the thrust bearings. I replaced the deep groove ball bearings, which actually most of these have deep groove ball bearings in them when they ship them to you, and they say they're angular contact, but they're not. So I bought angular contact bearings for all these and shimmed them to give them preload and assembled them. So there's no backlash in this machine. It's very stout. The double Y motors have a lot of power. The X has a lot of power. I don't have any problems with it losing steps. It cuts extremely accurately, you know, for wood. So I was pretty impressed with how well that all turned out. Got the cable chains mounted to the top of this angle aluminum, and the angle aluminum is also mounting this other cable chain. And I made it so that it would have a pass-through here. So if you wanted to lay something long and flat inside the machine and cut it end to end, you definitely could, and it could stick out the ends too. So he was saying he wanted to kind of surface tabletops and do that kind of stuff, and he'll be able to do that by either laying it all the way through the machine this way, if it's a narrower piece, or he could go, you know, 4 feet wide and machine it this way in sections. You know, this is about as big a machine as he wanted in his garage. So it's probably bigger than most tabletop machines, takes up about the same space, you know, because it's got its own base station and everything. It rolls around in these casters. These are leveling casters too, so basically you can spin these things and it puts this little rubber foot down and you can level it on these feet. So I wanted it to be portable in case he wanted to move it around and put it in different parts of his shop. And what else? Yeah, so, you know, I think for a few months of tinkering around in the garage, I'm sure my wife would say I spent too much time on it. I think it came out really nicely. He seems to be happy with it. We've been making little things like this just to kind of get his feet wet, because he's not really used to doing CAD and CAM, and you know, it's not my machine, so I have to get him up to speed how to use it before he takes it back to Michigan here in a couple days. So we've been piddling around making stuff like this. And what else? Oh yeah, I showed him how to do inlays. This is with a V-bit, just a 90-degree V-bit, cutting it out of dissimilar pieces of wood and inlaying it. So had to figure out how to do that myself in Fusion. He was trying to use easel and all this other stuff to do inlays, and I was trying to keep him working on Fusion because Fusion does everything, and had to kind of invent a way to do that. Showed him how. So yeah, this came out really well. Really happy. Hope he likes it. Just showing a couple more details. Just put like little nice features, USB hub, so that you wouldn't have to plug anything in down there if he has like a little thumb drive or whatever. Got a pendant that I actually got with my old CNC machine that I never used, but actually works in UCNC really well. Got a nice emergency stop, you know, just in case it starts screwing off on him. He can just hold this and use it. So yep, so got all kinds of functionality here. There's my little mister here. Not sure how much aluminum he's going to cut. I told him he can basically just use it to make jigs and, you know, little hardware for his projects. He seemed happy with it. I don't know if he's actually going to do that. He seems more like the, you know, wood or nothing kind of guy. But yeah, so a lot of parts on here are 3D printed. Like I printed these guys. These hold the inductive sensors, proximity sensors for the limit switches, and there's a little screw in here that you can adjust and move this front and back to square the gantry up. So the left Y motor and the right Y motor can be squared and homed independently to square it up. What else? I 3D printed like pretty much all of the inductive sensors, just brackets and other fun goodies. So yeah, this keyboard tray actually folds up into the machine. So, other way. So it actually folds up into the machine and stores itself. So it doesn't take up much space, and this tray also kind of folds up. It's kind of a nice thing I found on eBay. These motors have tons of power. I don't know why people use or suggest people use like closed loop stepper motors. I mean, I'm sure they're great. If you start missing steps, it's nice that it would error out. But these things will probably, they have enough power to where they don't, I think the spindle would also be stalling out if they're about to stall out. So really the work is going to be trash either way. Haven't had a problem with them losing power. They're running 48 volts. They've got tons of torque, and the axes move pretty fast and have plenty of power for what this machine is. So yeah, a few more details of the cabinet here. So this, even the I made the 3D printed some fan shrouds for the drivers there. Just all kinds of piddly stuff in here. Tried to label everything. Even put, this is important actually, the flyback diode on these, if you're controlling these relays with the same power supply that's doing other things in the system. You definitely need those, because if you don't have those, you'll see like all the lights on your control flash super bright when you turn off the the solenoid, which is fun. So definitely add those things. The breakers, there's a breaker for the 24 volt loop. What else we got in here? That's just a cheap Chinese VFD. Works great. Doesn't have a brake resistor or anything, and still stops the spindle on a dime. We can show you. So I'm going to crank this thing. I was just running it a minute ago, but we're going to crank this thing to 18,000, and so it's up to speed, and it's off. And it's real quiet. These water-cooled spindles are great. It doesn't make any noise. This doesn't leak. The run out at the tool is like 4/10 or something like that, or less. I think it might have been 3/10 that I measured. It's real low. I had another spindle that I was going to put in here that had like 4 thou or 5 thou run out at the taper. So a couple tenths at the tool is great. So yeah, these spindles are hit or miss. This one was actually pretty good. It was like 140 bucks on Amazon, and it was prime shipping too. So it got here pretty fast, and it works great. Haven't had any problems with it not having enough power. Got a little cheapo dust boot that I had to put bolts through to hold these bristles on. I've been using up to 1/2-inch tools on this, and it just chomps material. So we do I was doing a lot of roughing with this 1/2-inch compression bit, and it doesn't seem to bog the machine down at all, either the spindle motor or the axis motors. So it's got tons of power. And this is the little V-bit we were using. He's got like an insert bit that he bought that he's real happy about. So that's really what he's going to use for this kind of stuff. Definitely need earplugs with this thing, because sometimes the tool gets real loud, and the vacuums are pretty loud too. But yeah, I mean, machine works great. It's been a long video, but just wanted to share everything with you guys. And, my thoughts on different parts. Like you see a CNC, it's been pretty good. The 2017 screen set is good, simple. Probing works well. Yeah, everything just works. So really the only thing I would change if I did it again was I'd probably use a heavier Gantry extrusion, something like an 8160 or something like that. And I would definitely not use these gold manifolds. They just are junk. So yeah, just busy around, show you a few more details. I probably need to get the right size bolts for some reason, a little long. And then I screwed up here. I was using different couplers before, and I didn't really like how this style coupler was working for the X and Y. It had too much run out. For one, it had too much run out on because it's actually like the support bearing for the Y motors as well. So this style has less run out, and it ends up being a little longer. So I had to space this motor out on. Yeah, don't worry about that. So yeah, just took a lot of time building all these parts, and I'm really proud of it. So I hope he likes it. I can't wait to get more furniture and doodads from him when he's using this thing.